Hello everyone, in today's video we'll be discussing find the maximum number of marked indices. In this video, our goal is to find the maximum number of indices that can be marked, and index can be marked if it follows this particular criteria, and we're allowed to apply this criteria any number of times. Okay, so what I mean by that is, let's say we are given an array of integers like this 3, 5, 2, 4, and our task is to find the number of indices from this array that meets this particular criteria. So initially all the indices are unmarked, right? So something like this. So these are the indices, right? From here we can start picking these two indices, right? Because these two indices actually follows the criteria here. So you will see that 2 times 2 will be 4, right? So 2 times 2 will be 4, which is actually lesser or equal to this thing, right? This is 5. That's why we are actually going to mark these two indices, right? So however, for this given input, we don't have any other indices that actually satisfy this particular criteria. Thereby, the maximum number of marked indices for this given input will be 2. Now let's jump into the coder bit. To solve this problem, we need to consider the fact that we want to mark as many indices as possible, right? So one possible approach could be to sort the array in non-decreasing order, which would actually ensure that we start from the smallest number, and then we will iterate with the 2 pointer and check how many indices actually matches this particular criteria. Okay, so this is what we'll be actually coding. So let me start. So let me start with the sorting method. Nums. Okay, after that let me check how many elements we're actually dealing with. So in this case, integer in will be nums of size, right? So after that we can actually iterate through this array, this nums array, with 2 pointers. So let's say we'll have I and j will be the 2 pointer we're talking about, where I will start from the initial position. So we can say something like this: I will be 0, and the j will actually start from the mid positions, right? So this will be the mid positions, right? And then what we can do is we will actually want to actually continue this process, right? Until this I actually reaches to the midpoint, or this j actually reaches to the end. So we can do something like this: I less than n by 2 and j less than n, right? And now that we're within this particular loop, right? Inside that, what we have to do is to check this particular criteria. So we can quickly say 2 times nums of I is less than equal to nums of j, right? Okay, and here we can actually move both pointers within this array, right? Or within this particular criteria. So when the criteria actually matches for a particular index, right, we have to mark those indices, and for that we actually need an additional container, right? We need an additional container. We will need an additional container, right? Which can actually hold the information of those marked indices, right? And in the end we will actually count the elements, number of elements we have inside that container, right? So that could be one approach. But the question is, do we really need to mark those indices? Because in the end, all we care is the number of marked indices, right? Here, you can look over here, right? We actually don't need to return the indices that actually matches this criteria. So this is why instead of actually marking those indices, right, instead of going with these approaches, because if we go with this approach, this will actually will take an additional order of let's say additional space, right? So if we have any element, then the space complexity will be order of n, right? So this is why instead of actually storing those informations, we will actually maintain a local variable to keep track of the count. Okay, so we'll not go with this approach. We'll not go with, let's call it approach 1. Okay, so we'll not go, not optimized, not space optimized. Okay, so instead of that, what we'll be doing is, let's call it approach 2, maintain a local variable. Okay, so what we'll be doing is we also need to declare actually a local variable. Let's declare a local variable. Let's call name it res. So initially the value will be 0. Okay, and here we can say if it matches this particular criteria, we simply want to increase the local variable with 2. Okay, else if it doesn't match, right, then what we want to do, we simply want to move the j ahead, right? So I think that's pretty much everything. So let me see if it passes the test case. Okay, I think we have made some mistake. Let me check. Non-void. Okay, let me check now. Yeah, so looks good. Let's submit. Okay, so it got accepted. So now let's talk about the time complexity. So the time complexity for this problem will be order of n log n. Okay, so the time complexity will be order of n log n, right? And this is mainly because of this sorting method, right? And for the space complexity will be order of 1, because we are actually not storing any information because if we go with this approach 1, on that case this space complexity will be order of n, but here we are actually only maintaining every information within this res variable, which is actually will take constant space, thereby the space complexity will be order of 1. Okay, so yeah, so that's it for today. Thanks for watching, and I'll see you in the next one.